Hello everybody, welcome to my presentation. This is joint work with Göhring and Amsler. If we annotate data, we not only measure the quality of the data on the basis of inter-annotator agreement, we quite often also harmonize in order to create a single gold standard. Majority vote-based harmonization is a simple option. We keep only those annotations that most annotators agree upon. Of course, majority vote-based harmonization only is valid if the majority is right most of the time. So we found counter-evidence for this claim in the area of sentiment inference. So majority vote-based harmonization is inappropriate for sentiment inference annotation. We provide first statistical evidence for that claim, and we suggest to instead leave the distribution of opinions intact. Let's start with an example. Take the following sentence. The former defense minister Mattis accuses Trump of deliberately splitting America. I guess we all agree that in a situation-specific manner, Mattis is against Trump, the red arrow here, and in favor of America. But how do we know? Well, verbs do play a crucial role. So the verb accuse expresses a contra-relation. But what about the pro-relation? Well, that is sentiment inference. You might have a look at the demo under that web address. So then the annotation task is we would like to annotate pro and contra relations like Con, Mattis, Trump, but we also postulate the existence of what we call role framing effects, that there are negative effects, in this case on Trump. We use other roles as well, positive or negative actor, for example, but I don't go into the details here. So the initial goal was to produce a gold standard, and we quickly find out that the task is highly subjective. So if you haven't heard about sentiment inference so far, don't worry. It's just another name for sentiment implicature or attitude prediction. The question there is, who is in favor of or against what or who? Sentiment inference also shares some similarity with stance analysis. Here, the question is whether the writer is in favor or against some controversial topic. After all, what is sentiment inference? This is our definition. Sentiment inference is the determination of all pro and con relations and role framing effects that a text gives rise to. The crucial question, of course, is what do we mean by gives rise to? How does a text give rise to an inference? So we already have learned that such a relation could be lexically induced. So that was the con relation evoked by accuse. And I already said that there is an inference, there might be an inference involved. The example of the pro relation between Mattis and America. It is derived by the application of an inference rule, and this is the inference rule. If an opinion source A is against something that is negative for target B, then A is in favor of B. In our example, Mattis is against the splitting of America. The splitting is negative for America, so Mattis is in favor of America. But now that we have opened the door for subjective inferences, you might say. How far should we allow these inferences to reach, to go? For example, should we allow for word knowledge to be used as well. Me, I believe the following rule is true. If someone criticizes Trump, then Trump is against that person. Consequently, I should annotate this counter-relation between Trump and Mattis. So the question then is, would such a focus on subjective reasoning be the death of the idea of harmonization? And I guess not necessarily, because the plausibility of inferences still is in question. We just have to talk it out. And then it might turn out eventually that the majority most of the time prevails. And then majority voting based harmonization would be saved. Well, before we have a look at the empirical part of that talk, let's have another example. Given the sentence, Jim Grace, whose books depress many readers, seemed like the most cheerful man on earth. There's a negative effect. So here are a couple of possible inferences. There certainly is a negative effect on the readers. This is literally expressed by the verb express. And maybe then the readers are against the source of that negative effect, namely the book. They might even be against the author of that book. And in a sense, the book is against the readers. Clearly, this is not an attitude. So we take a wide definition, a liberal definition of these relations. And there are a couple of other possible inferences. So I'll return to this example in a minute. Now let's have a look at the empirical setting. We extracted 500 sentences from newspaper articles that contained at least one word from our verb lexicon. We had 4 annotators. They annotated every sentence. So we have 4 annotations for each single sentence. The annotators were trained beforehand on the basis of 100 sentences from a different source, and the guideline were developed on that basis as well. And this is the result. This is the inter-annotator agreement measured on the basis of Fleiss kappa. We here see the frequency, the number of annotations for particular relations and effects. So for example, we had 383 annotations for the pro relation. And as you certainly have spotted already, the inter-annotator agreement is a bit disappointing. We only have a slight agreement. And the question, of course, is why? We decided to discuss the reasons for it. We decided to harmonize part of the data on the basis of discussions. So we selected 50 sentences for that reason. And this is the distribution of agreement in terms of votes. So most of the time, only a single annotation was provided, but in almost 20% of the cases, 4, 3, or at least 2 annotators decided to annotate a relation. So let's come back to the example sentence. These 5 annotations are suggested by the annotators. We all agreed that there's a negative effect on readers. 3 think that there is a counterrelation between the book and the readers, and there are single annotations, a correlation between readers and grace, between readers and book, and a negative effect on grace. So in the course of the discussion, we could convince the 4th annotator to adopt annotation 2. And we could convince the annotator of annotation 5 to drop it. The annotator of annotation 3 sticked with her opinion, and after some discussion, the annotator of number 4 gave it up. So that's the kind of action that took place. We have adoptions, we have deletions, and there is persistence of annotations as well. And this is the distribution of revision decisions. So we can see for each annotator the number of cases of revisions, given that there are a number of counterwords. So for example, the 4th annotator 12 times revised his decision, given that there are 3 counterwords. The same annotator revised his decision 10 times in the presence of 1 counterword. And this is an amazing finding, because it seems to suggest that the inclination of revision is independent of the number of counterwords. This is at least true for the last 3 annotators. 12 revisions, 11, 8, 8, 12, 10. And actually that is not proof, it's just what in German is called Augenschein. But of course we could use a statistical test in order to prove it. So the null hypothesis postulates independence. So the probability the voter changes his mind given any number of countervotes equals the probability that that voter changes his mind. We could exemplify this on the basis of the table by maximum likelihood estimations. So for example, the probability that the 4th voter changes her mind given that there are 3 counter voters is 0.22. So there are 12 cases out of 54 cases where somebody changed his or her mind on the basis, given that there are 3 counter voters. We can also estimate the probability that A changes his mind, and it's 0.26. And although these 2 numbers are not totally identical, they seem to support the hypothesis that there is independence. And the alternative hypothesis is that the number of counter votes does have an impact on the inclination for revision. We applied Fisher's exact test. This is just the table here, and the result is that we get a p-value of 0.32. This is a rather high value, far away from any reasonable threshold, so we couldn't reject the null hypothesis, which states that we have independence. And as a consequence, the majority-based harmonization does not produce the best gold standard. That is the finding. On the other hand, harmonization by exhaustive discussions is time-consuming. So it's unrealistic that it is used. Clearly, we should harmonize as much as reasonable in order to get rid of errors and annotation omissions. But we would argue to leave the distribution of opinions rather intact, to learn on the basis of a distribution of opinions. So in a machine learning setting, we could use the number of votes as weights, and single voted relations would of course be very prominent but still reproducible, and which is preferable since there are often are strong, enforceable opinions. So that's it. Thank you. We would like to thank Noemi Eppli, Sophia Conrad, and Andreas Säuberli for their contribution to this work. We also would like to thank the Swiss National Science Foundation for funding. And I would like to thank you for hopefully attentive listening.